Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You begin by selecting a base model size that fits your GPU budget. Pick 7B for speed or 13B for better capability. Once done, assemble 100 to 10, 000 curated input-output pairs and remove duplicates so training is efficient. Make sure to format everything as JSONL with consistent fields, then split into 80/10/10 train, validation, and test sets. You will already be in the fine-tuning flow without wasting time on trivial installs. Now configure training. Choose low R-ray if you need efficiency or full fine-tuning for maximal change. Pick LR between 1E5 and 5E5 and use FP16 for speed. You should set batch size to 864 and apply gradient accumulation to match effective batch memory. Once the job starts, monitor training loss and validation metrics and save checkpoints every few hundred or thousand steps. If validation worsens, reduce learning rate or stop early to prevent overfitting. You finish by evaluating on the held-out test set and checking metrics relevant to your task, then run thorough safety and prompt sensitivity checks. Once satisfied, export the tuned weights and test locally before deploying with batching and rate limits. If the model hallucinates, degrades, or overfits, try lowering the learning rate, adding or cleaning more examples, using data augmentation, or freezing early layers. One key troubleshooting tip: if loss diverges, immediately reduce LR and revert to a recent good checkpoint.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.